Fantastic. So it's, I think we can move on to our next speaker, who is Luiza Antonie from the School of Computer Science at University of Guelph in Ontario in Canada. And her research interests are in data mining technologies and methodology for interdisciplinary and applied research, focusing on record linkage, classification, data integration. And she's going to talk to us about tracking people over time in 19th century Canada. So
thank you.
Thank you.
Thank you for the introduction. Yes, hello everybody. I'm going to be talking about building a record linkage system to link Canadian census. So this talk is somehow related to Evan's. He already talked about some of my slides, so that's good. And I'm going to be talking about our experience in really linking the Canadian census. I'm coming from University of Guelph. Some of you were asking me yesterday where that is. It's in Canada, about 1 hour west of Toronto. Which is the data that we have. We actually have quite a lot of data. All these are 100% census collections, starting in 51 in Canada, going to 1911, and then you can see sort of here in this picture that I'm including some of the U.S. Census collections. Why we're doing that is because a lot of Canadians actually migrated into that period, so we might have people crossing the border, moving to U.S. for a while, then moving back, and so on. So at some point we want to integrate with the US data as well to be able to study migration and find those people that moved. What's the system and the result that I'm going to be presenting today is really linking 4 Canadian census collections over a 30-year decade. So linking from 71 to 81 to 91 and 1901. Okay. So that's been done. I'm going to show you the system that you use today, and then I'm going to show you the results that we got. So why is this exciting? This is really exciting for historians and economists that study history and historical trends. As Evan was saying, no privacy issues here, so we have the name, so you don't really worry about what we're going to discover, although you may imagine somebody being maybe upset if you discover that some of their ancestors were living in a prison at the time or something. So you can imagine some implications, but we're not concerned with that. So really, what are the challenges and opportunities? Really, this application, this comes from the area of social sciences or historians, economists that have interest in studying people and societies over time. And what's their challenge? Their challenge is to actually create longitudinal data from all these data collections that they have. Okay? So then they don't have the tools or the knowledge or maybe the interest to actually do that. So that's where computer scientists come into play, and they want to help and build systems for these users to be able to create longitudinal data. But really the challenge is to create reliable longitudinal data, because this kind of application or this kind of problem comes with its issues, data issues, and then with some very specific requirements from the historians. Okay? So one of the really specific requirements is that you want to have high quality links. Okay? So really what we're trying to maximize here, we're trying to maximize precision. We do not care about recall, but you want to make sure that your precision is very, very high. Okay? And then evaluation is very hard, because we're talking about all these data collections. They might not seem very big in terms of scale when you compare to US data, but the thing is that even when you link these collections, it's impossible to evaluate all the results, all the longitudinal data that you're getting. So how do you evaluate what's the error so that you know what's happening with your results? You've seen on Evan's slides how the census looks like. I admit that for me it's very, very hard to read, so I don't really know how people that digitized did it. I have some of these pages in my office just to sort of remind me where the data is coming from. And as you see right here, it was transcribed here. But as I'm saying, for me, some of that handwriting, it's quite hard to read, and this image is not even that bad. So there are some that are much worse. I really can't tell what's been written there. So luckily, we have people that transform all these handwritten documents into machine readable that we can work with and try to do record linkage. I won't go over the definition. Everybody knows what record linkage is in this room. So I'm going to tell you the system that we developed. So the system that we developed, we started for linking the 100% of the 87 Canadian census to the 1881 Canadian census. Okay, and what's the size of the problem? So what are we dealing with? In the 71 Canadian census, we have about 3.6 million records, and in 8081 one, about 4.2 million records. Okay, so this is the size of the problem. Now, what we want to do, we want to actually build a system to automatically link these two files. And what are some of the data challenges? You've heard some of the speakers talking about some of these challenges already. These are just some examples from our data. So we have imprecise recording, and why that is happening. Evan gave a really nice summary of where errors were actually introduced at several stages in digitizing this data. So these records, so these two sets of records are coming from some expert links. So we know they're the same people. We know that R1 is the same as R4, R2 matched to R5, R3 to R6. So again, these are expert links. We're very confident in them. We know they're the same people. But you can see that there are misspellings in the names. Some of the names might have just an initial, not even a full first name, let alone to have middle name or so on that you can use. At least in this data that I'm showing is because it's the data that I'm working with, we don't have too many issues with the gender, birthplace, and marital status, because those have been standardized and coded by expert historians. So mainly our errors are going to be in the last name, first name, and the age reporting. So as you can see, the age for the first record, it's 12. Again, the census was taken 10 years apart in Canada. So you would expect, of course, the person that was 12 in 71 is going to be 22 in 1881. But that's not the case. You can see that the age was reported to 23. For the third record, it was 36 in 71 census, and then reported, maybe rounded to 45 in 1881. So we have all these issues where the age is not reported properly. And of course, you might even have in some cases incomplete or missing data. Now, another data challenge that we have, and it's quite an important one, and you're going to see later on when I show you results why actually the linkage rate that we're getting is actually so small. It's mostly because of the small number of attributes that we're using for linkage. What's going to happen? It's actually that using only a very limited number of attributes is going to lead to extensive duplication. So what I mean by that, if you're just using last name, first name, gender, age, birthplace, and marital status, you can see in the top table that all the records of Mary Barnes, born in Ontario, single, around the age of 10. Okay? And then in the bottom table, you have all the Mary Barnes in 1881, born in Ontario, single, age around 20. Okay? So just by looking at this table, there is no way, even humanly, let alone automatically, there is no way to know exactly which record should be linked to which one. So we will never be able to actually disambiguate and link these records using only this limited number of attributes. So what's the overview of our system? It's just a pretty basic record linkage system that, again, you've seen in some of the talks before. We have the two census collections. Of course, first we're going to do lots of cleaning and standardization. We're going to perform some blocking. Then we're going to compare similarities of pairs of records, and then we're going to use a classification model to actually evaluate those pairs and then decide if they're a match or a non-match. And that's how we end up with our match records. So we did, as I said, some extensive data cleaning. We removed, so in this case, again, it's coming from how things were enumerated, because some of these things may not happen or you may not see in more current data or other types of data. But in the census, you may find things like the age being reported is 2 1/3. Or you may have somebody just writing there, okay, what's your age? And then it was recorded about 60. Okay? Or especially we have lots of babies, for babies being reported as 1 month, even 3 hours, and so on. Okay? So we just decided to standardize those and then just transfer them to integers, just to the closest age that we would have for that record. Then for the names, again, we've done some standardization because some people might report titles, though a very limited number, so we decided to just drop titles. We have an issue that we have to deal with in Canadian data is that we have some French-speaking people, so there are French and English. Some of the French names, of course, they're going to have accents. Okay? The problem is that they're not properly reported and they're not always reported. What's happening is that sometimes English enumerators are sent into the French in regions where French people live, and then of course when they're going to write the name, not only that they're not going to spell it right, but they're definitely not going to record accents. Okay? So then, because it was a lot of inconsistency there, we just dropped the accents. And for some of the Scottish population, we had some interesting observations in the names. We ended up with some of the Scottish names, the Mac being recorded at the end of the name. Exactly why that happened in the census, we don't know, but it was in quite a big number of records, so then we decided to just move it at the beginning of the name, again for consistency, to be able to do the linkage. For the marital status, we had several original strings in both English and French, and then we just coded those with some numerical codes to account for single, married, widowed, and divorced. So what are our features, how we construct them, and how we do the comparison? So again, what I'm talking here is really a system that was designed as it was with the requirements coming from the historians. So what's happening is that the requirements was to use a very, very limited number of features. So in this case, we're using only last name, first name, gender, age, birthplace, and marital status. So pretty much what we're doing, we're restricting all our linking features to time invariant characteristics. Okay? Or of course, you might say, well, marital status can change, there's not really time invariant, but there is some predictable function that we can use that, and then we can use that function in the similarity to account for the changes in marital status. But everything else should stay time invariant throughout the life of a person. So the idea is that although we might have the information in the census about location, occupation, family context, religion, origin, and other characteristics, we're not using any of those. Okay? So again, why these requirements? Because this might seem counterintuitive, maybe especially to some of the computer scientists in the room, where they would want to use all the data that we have to link as much as possible, and that was my first impulse as well. But then discussing more about the problem, it turns out that, for example, if you want to study occupations and you want to learn or understand how people change occupations over time, then you can't use that in the linkage process. Because what would happen if you would use that in the linkage process, then definitely the resulting links that you're producing are going to be biased towards those people that stay in the same occupation. So then when you're performing the analysis, you're going to lose lots of people that change occupations. So you're not going to be able to perform such an analysis. So that's why we're using a very limited number of features. How we compare features? We used Edit Instance and Jaro Winkler for last name and first name comparison. For the age, we have a binary function where we actually allow for a plus or minus 2 years, because as we've seen in our examples and we observe in the expert data that we're having, that people misreport their age, and plus minus 2 accounts for most age differences that we've seen. I won't go into details, but we actually even try to use sort of incorporate the distribution of age and use that into the model, but that really didn't buy us anything. So in the end, we just decided to stay with a simple function. Then for the gender and birthplace, we're just using the function, another binary function where a match is 1 only if the two agree on exact match. So essentially, we're doing blocking by gender and birthplace. And for the marital status, again, we have a binary function, which is actually going to be 1 if there is a valid change in the marital status, or if it's going to be 0 if there is an invalid change in the marital status. So for example, the function is going to take a value of 1 if you're going to go from single to married, but it's going to take, if we're comparing records that go from single to married, but it's going to take a value of 0 if you go compare a record from going from married to single. And why is that? It's because of how the enumeration was done. So if you're unmarried at the time, then but you were married before, then you had to declare as being divorced or widow, and that was recorded in the census. So that's why you couldn't go back from being married to being single. So these are the kind of things we take into account when we calculate the similarity for the marital status. Then, as I said, well, essentially we're doing blocking for birthplace and gender, since we forced an exact match there. But in addition to that, we're actually doing blocking by first name codes. What does that mean? It means that all our first names in the 71 and 81 have been actually manually coded by expert historians to actually put them together if they're coming from the same name or the same root. So for example, Eliza and Beth, they're coming from the same group belonging to Elizabeth. Okay, and then we're using that in our blocking. In addition, we're using the first letter of last name because we notice that's pretty good when it's reported. So it's you rarely find errors there in the first letter of last name. And then just to reduce the number of candidates that we're getting, we enforced some thresholds on some of the similarity measures that we discovered looking at our expert data. Again, trying to maximize precision, not caring as much about recall. Now, that's something that we're fortunate to have. It's actually training data, because most of the projects lack training data, and then it's very hard not only to build a classification model, but it's also hard to actually evaluate your model and evaluate what's happening with what you're producing. So we actually have training data that is coming from 4 separate projects, but all those projects, they linked records from 1871 to 1881. So exactly the 2 census collections that we're interested in. And starting from this, which we call true links, so the true matches coming from experts, we generate our label data. So the true links are, of course, our positive examples. Then we did a cross product and doing the same thresholding and blocking and so on. We get our negative examples as well. So then we have a binary classification problem. Each pair of records is going to be represented by the feature vector calculated as I discussed before. And therefore, the classification model, we just did the basic support vector machine with an RBF kernel. And then the classes are going to be matched. It means if there should be a link between those 2 records, or a non-match if there shouldn't be a link between those 2 records. Okay, so now here is this table. I show you the evaluation for our system. So we did a 5-fold cross-validation. And then these are the true positives, false negatives, true negatives. And then just as an overall evaluation, the area under the curve, okay, which shows you how well the classification system is doing. So based on this, you would say, well, the classification system is doing pretty well. So the classification model that we have is doing reasonably well for classifying links. Now the problem is that this evaluation again is done of 5-fold cross-validation on the training set that we have. Okay? But now we're actually going to deploy this system. And then link the two full collections. So what's going to happen is that in the end we're going to end up with one-to-one links, which means that a record has been linked to a single record in the other census collection, with multiple links where a record is linked to multiple records, or a record in here is linked to multiple records in this one, or you found no links at all. Okay? So taking that into consideration, now we do again evaluation, and now of course when you have the multiple links or no links, then you have to take those out of the evaluation. So what's happening is actually that you end up with a true positive rate of the recall of 40% and the false positive rate, which is 1 minus precision of 5%. Okay. I have to go fast because I have only 5 minutes and I have lots of results to show you. Sorry about that, but we can discuss more later. So I want to say that we actually took this system that we developed from 71 to 81, and we used the same system to link 81 to 91 and 91 to 1901. And these are the number of links that we're getting. You can see the decade in the table and then the linkage rate with reference to the census that we're linking from. So we're linking about 15% of records. Again, these are one-to-one links, so these are only records for which only one record was linked to. Now, because we're having lots of multiple links, we were thinking, okay, what can we do to disambiguate some of those? Okay, so now we're trying to add a new step to our linkage system. But again, just following the first one. So the first step, producing just the least biased links that we're producing on a limited number of attributes. And now we're trying to bring in the family context just to disambiguate multiple links. So what's happening, you might have two families, this household in 71 and this household in 81. And you can see with the black lines are the one-to-one links that we generated with our system. And the dotted one are those records that actually have been linked to multiple records. Okay? So now we're actually using this family information, these two households, to disambiguate some of those multiple links. So what is happening if you're just looking at this X link, okay, you can see that this record was also linked somewhere else, but because most or lots of other records in the family have been linked to this family, then we're saying, well, we're confident that this is the correct link, so we can drop the other one. Okay? So we're doing this, and we're using set similarity measures to disambiguate some of these links. And when we do that, we end up with almost doubling our linkage rate. So we go from 14-15% to almost 32%. Okay? So definitely we recover more links. But now, really the question is, did we introduce any bias? How is how are the distribution of the links that we're producing compared to the distribution of the census that we're linking from, and so on. So here I'm just going to show you some results, just looking for some attributes. And for all the graphs, I'm going to show you the distribution. Then I'm going to have sort of 3 groups for the 3 linkages that we've done. Okay? And then in the blue is the reference, which means that's the distribution in the census that we're linking from. The orange one is the pairwise, so where we use just the limited number of attributes. And then the sort of grayish one is where we use family context to do some disambiguation. What you can see here is that if you're looking at males, it's just by gender. You can see that we overrepresent males in our data, and we underrepresent females in the link data. When you're looking at age groups, you can see again sort of a correlation with the previous one, that we underrepresent young females. Okay? And using family information, we increase the number of kids. Why you underrepresent young females? This is sort of expected and known for our problem. What's happening is that we cannot link females that went from single to married because most of them, they changed their last name. So we know that we will not be able to link those people, those persons. Then if you're looking for marital status, let's go to the one by gender, since I'm running out of time. So again, you can see that for females, we're underrepresenting here, again, because we're not able to link those that married. If you're looking at birthplace, you can see that we're overrepresenting some of the birthplaces, but we don't seem to have a lot of bias in this, I would say. Maybe with the family, somehow it seems that we disambiguate most people born in Ontario. Something to look into to understand why we're doing that. If you're looking at origin, this is an interesting one. And again, this is really relevant to the Canadian data because what's happening is that we're definitely underrepresenting French in our data and we're overrepresenting English. Okay, so we know that's happening possibly because of the data, because of the names that we can't really link. There is another hypothesis that because French people at the time were more illiterate than the English. So there are a lot of hypotheses there that we can test when we have more characteristics from the census. Then religion, which again it can be sort of correlated with the origin. We're underrepresenting Catholics and overrepresenting Protestants. Okay, and again Catholics because most of the French born were Catholics. I won't go over this since I'm out of time. This is just some example because some of you were asking me yesterday what are people doing with this data. So we create the longitudinal data, what kind of studies you do with that. It's actually looking, for example, at occupational transitions. So in cross-sectional data, not longitudinal, you might be able to say something about the occupations in 71 as opposed to 81. You can understand the categories, but you don't really know the transitions. So then when you have the longitudinal, that you can actually say something about net flow of workers and how it changed from some sectors in others, where people moved out of which sectors and then in which sectors, because you actually looked at those people, how they change occupations. Okay, thank you everybody. And sorry if I took too long.
I think we can take a quick question if there's something. Yes, yes.
You arrived at a linkage percentage of about 30%.
Yes.
But now I remember Evan told that in censuses there were 70% of the people who give only their first name. So if you just, well, that might...
Let me just clarify, that was on the first name, 70% of people only give one name. So there's no middle name. Everyone gives a last name. I mean, that's the same with your...
Yes, it's pretty similar in the Canadian.
That was a little confusing. That's one name and their first name.
Okay, but how is the situation in Canada then?
Very similar.
The Canadian data, I think, is pretty similar to what Evan was saying. So most people, of course, they're going to have reported their last name, and in the first name, you're probably going to have mostly a single name, so one string that you can compare against. Very rarely you might have some middle names or maybe a middle initial, but that's not very reliable, and sometimes it's reported and might not be reported in the later census. So we're still pretty much making our decision based on a single first name. Yes.
Okay. Anything else? No, then can we thank both the speakers for this session, and it's time for lunch.
Thank you.